While colonizing Mars is already an extraordinary goal, there's a more ambitious concept that captures the imagination of scientists and dreamers alike: terraforming the red planet. This process involves modifying Mars' environment to make it more Earth-like. Warmer temperatures, a breathable atmosphere, and perhaps even flowing water. It's the ultimate long-term vision of human expansion beyond Earth. Terraforming sounds like science fiction, and for now, it largely is, but the science behind it is evolving rapidly. As technological capabilities advance and our understanding of planetary systems grows, terraforming is shifting from a fantasy to a real topic of exploration within the scientific community. Let's start by understanding why Mars needs terraforming in the first place. Mars has a thin atmosphere, composed of over 95% carbon dioxide, with barely any oxygen. Its surface pressure is less than 1% of Earth's, and it offers no protection from harmful cosmic rays. Water, in its liquid form, cannot exist on the surface for long due to the low pressure. Temperatures frequently plunge below after 80 degrees, making it inhospitable to unprotected human life. If we wish to make Mars livable without permanent domes or suits, we need to completely alter its surface conditions. This leads us into the incredible science of planetary engineering. One of the most talked about strategies for terraforming Mars involves releasing greenhouse gases into the atmosphere to trigger a warming effect. The concept is similar to what causes global warming on Earth, but in this case, it's intentional and controlled. The idea is to kickstart Mars into a warmer state that can eventually support liquid water on the surface. Scientists propose using massive factories or orbital mirrors to release or reflect energy onto polar ice caps, which contain carbon dioxide. If these caps could be melted, they would release even more greenhouse gases into the atmosphere, thickening it and raising the planet's temperature. This warming feedback loop, once started, could transform the planet over time. Another idea involves importing ammonia-rich asteroids. Ammonia is a potent greenhouse gas, and redirecting small asteroids from the outer solar system to crash into Mars could help enrich its atmosphere. This, of course, is far from easy and carries significant risks, but conceptually, it's not impossible. More futuristic ideas include genetically engineering microbes to survive in Martian conditions and begin the process of oxygen production. Just as cyanobacteria transformed Earth's atmosphere billions of years ago, synthetic biology might help Mars start from scratch. These microbes could be designed to withstand high radiation and extreme cold, extracting minerals and producing gases that contribute to atmospheric development. Eventually, we might see the first signs of vegetation, engineered plants that can grow in Martian soil, adapted to absorb CO2 and release O2. Forests may be a distant dream, but in the beginning, even patches of moss or algae could signal the start of a living ecosystem. However, terraforming is not a quick process. Realistically, scientists estimate it could take hundreds or even thousands of years. And that's assuming we have the technological and ethical green light to begin. The transformation of an entire planet is not just an engineering challenge. It's a moral and philosophical one. Who decides how a planet should be changed? Does Mars, as a celestial body, have its own intrinsic value untouched by human hands? And if microbial life exists or existed there, do we have the right to alter their home irreversibly? These are the kinds of questions being debated not only in scientific journals, but also in ethical think tanks and space policy forums. As we expand into space, our responsibilities as stewards of life become increasingly complex. From a technical standpoint, the road to terraforming Mars begins with smaller steps, building enclosed, sustainable habitats known as biospheres. These structures allow scientists to experiment with recycling air, water, and waste in closed-loop systems. Some versions might simulate the terraformed conditions of a future Mars, allowing human settlers to slowly adapt while science catches up. Even if full-scale terraforming remains centuries away, its foundational technologies are already being developed. Solar-powered greenhouses, advanced hydroponics, energy-efficient atmospheric scrubbers, and modular living environments are just a few of the innovations paving the way toward long-term Martian living. There's also a geopolitical aspect. Terraformation and colonization will require international cooperation, or competition. Just as Antarctica is governed by treaties ensuring peaceful scientific research, Mars might one day require similar regulations to prevent territorial disputes or exploitative behavior. Infinity. Beyond believes in promoting responsible exploration. The dream of terraforming Mars is one of the most ambitious projects humanity could ever undertake, but it must be done with careful planning, scientific transparency, and ethical foresight. Let's imagine for just a moment that this grand vision succeeds. Centuries from now, Martian skies are no longer pink and thin, but rich and blue. The temperature has risen to a habitable range. Rivers flow through canyons once dry for billions of years. Domes are no longer needed. People walk freely across vast plains, under forests engineered to thrive in their new home. Generations are born who have never lived on Earth, but instead call Mars their only home. The process would be slow and fraught with setbacks, but the result, a second cradle for humanity, would forever alter the future of our species. Not just a backup plan, but a new chapter. Terraforming is not just about Mars. It's about learning how to live better on Earth. Every problem we face in transforming Mars mirrors one we already struggle with here. Climate control, resource sustainability, ecological balance. In learning to create a habitable Mars, we might finally learn how to preserve a livable Earth.